Good afternoon. My name is Raphael Monten. I'm a business development manager for server technologies with Intel in the West Europe region. And it's my pleasure to be here with you and to give you the next 30 minutes an overview of what Intel is doing in the OpenStack space and also answer the question, OpenStack looks exciting, but is it already enterprise ready or can I use it, really trust it for my enterprise? So first of all, okay, what we see developing now is really an unprecedented business opportunity. Okay, we see a proliferation of multiple devices, different screen sizes, tablets, smartphones, phablets, you name it, proliferating, all of them generating vast amounts of data, which needs to be managed and secured. Those data allow us also to get new insights, okay, which are then the basis for even new undeveloped services which we didn't have before. And that's why we see a proliferation of new services, new business models starting up. Okay, I quite like the analogy the Economist made a couple of months ago. This is the kind of like a Cambrian moment. So analogy to the Cambrian explosion like 500 million years ago, where until then we had mostly simple life forms, and then life forms started to diversify, become more complex, and we saw a huge diversification of life forms developing. And the same is happening now, I think, with the new cloud environment that we see developing. But this also gives us new challenges, right? The old data center models can't keep up. We still have silos of network appliances, storage solutions, and compute instances, which are not based on the same standards and which are difficult to combine or to put in the same pooling resources. So network appliances, provisioning new network services still takes often weeks because they're still often proprietary appliances. Storage needs are growing very fast, 40% CAGR, okay, and all this needs to be managed, needs to be secured, and also, importantly, we need to keep costs down. So how could we keep costs down while the needs are growing so fast? And even compute. I mean, we've had virtualization for a while now. I mean, VMware basically pioneered virtualization on Intel-based platforms like 15 years ago. But even there we see that despite all the progress that has been made, only 50% of compute instances are being used today. So we definitely need something different and new to address these challenges. One of the evolutions, trends we've seen the last couple of years to address these challenges, and for companies, let's say, who were impatient and couldn't wait for public cloud to be enterprise ready, is this hybrid cloud phenomenon. So some enterprises have gone down this path, okay, have deployed what we could call private clouds, okay? And these could be still in-house, could be hosted, so on-premise or off-premise, as we like to say today. But this gave them, let's say, the best of both worlds. They could still have the security control that they had from in-house infrastructure or resources, and still get a level of automation that they didn't have before, so a higher level of efficiency. And this is something that we see well, continuing going forward also, this development of private cloud or hybrid cloud. Okay, Intel's vision for OpenStack for cloud is really about SDI, a software-defined infrastructure, okay? So what we see is basically, we've got actually an orchestration layer, right? OpenStack orchestration layer, which can then expose, let's say, certain platform features or attributes, and can share these easily, provision them easily across shared services, compute, network, and storage, okay? Intel's, I think, invested a lot of resources the last couple of years to make more of these attributes available, visible, and easy to exploit, okay? Also, not just in band, but also out of band. So attributes like power, performance, security, thermals, utilization, and location, so that we can do even geofencing or geotagging, things like that. For example, a little known feature in the last generation of Xeon CPUs is CUPS, compute utilization per second, which gives you its telemetry technology, which is now available out of band, and you can get a better idea of the utilization level of compute, I/O, and memory resources. Okay, so these are things that we do at the lower level, at the architectural level, to make it easier to exploit resources efficiently. So it's not a surprise that OpenStack has momentum behind it. Why is it? Because, well, first of all, you get the economics of open source, right? There's a huge community behind it. You get open source economics, no vendor lock-in. It's modular, right? We've got modular components for gradual implementation, and it's all standards-based, okay? And that's also why Intel is investing a lot in OpenStack. So we are part of different work groups, telco, enterprise. So we help steer, let's say, the priorities to make OpenStack more scalable and more easily deployable. Oops, too fast. Just to give you an idea of where we spend our resources in OpenStack community, OpenStack development. So really behind, well, let's say user appreciable benefits. So a lot of it is going into trust and compliance, right? Cloud needs to be secure or it will not develop as we would like to. Reliable high performance, okay, SLAs are important. Needs to be predictable. High availability. Cost reduction, right? Because especially in storage, with these phenomenal growth rates, we need to keep costs down, make it more efficient. SDN, make it more performant and make it all standards-based, as well as automation, deployability, and stability. So this is where we spend our resources, and in the meantime, Intel is also a top 10 contributor to OpenStack. I'm going to pick out some of these topics in the next section, so to explain a bit more what we're really doing. So first of all, security, right? I talked about, is it enterprise ready? So one of the technologies that we've already had for many years now is TXT, Trusted Execution Technology, which is basically hardware-based protection against rootkit attacks or other malware attacks. So you want to make sure that before a server boots or when a server boots, that the environment that is booting, be it an OS or a hypervisor, etc., can be relied upon and has not been tampered with. And that's what TXT is about. Basically, what you need to do is to add a trusted platform module to your server system, okay, which has, let's say, images and keys of which boot environments can come up and which can check with the keys if it has not been tampered with. Okay. Something else we've done is open attestation. Okay, we've developed an open attestation SDK, which we open sourced, okay, which can be used to develop applications on top of that. We've got our own cloud integrity technology solution pack, which is not open source, but is also relying on open attestation to build on top of that. And this way, we can really build an environment with TCP, Trusted Compute Pools, aware VMs, okay, that we really can say, okay, these sensitive workloads or VMs, I only want to run them on these systems where I know this trusted compute is running. These trusted compute pools are active. The other thing we were focusing on is having, well, making technology available to have reliable, predictable performance, okay? So there's a number of things we do at the architectural level, right? Building in new features, instructions in the CPU, in the processor. And what we're doing is making those available to the scheduler, okay? So that now you can really build a server farm and say, okay, these servers are better for, let's say, storage, or these are better off for video transcoding. So the feature I'm talking about is things like AES-NI, so encryption algorithms, which are accelerated in the CPUs already for a number of generations. Instructions like AVX and AVX2, which really make a big difference for integer and floating point performance. Quick Assist technology, which is today available as a PCI Express accelerator card to accelerate encryption algorithms, but also doing compression and decompression. And QuickSync Video is an example of technology we have in the single socket processors, which is very efficient, very performant for video transcoding and encoding. So I think today we've got the best video or the best performing video transcoding encoding capabilities in, for example, Xeon E3 or Core i7. Okay? So basically the idea is that, okay, you know which servers have these capabilities, and then you can say, okay, anything that has needs floating point performance, I want to make sure I've got servers with AVX. If I need a lot of video transcoding, encoding, you want to make sure you've got the Xeon E3 servers with the high-end graphics capabilities in it. Okay, automation, deployability, high availability. So this is still work in progress, right? So I'm just giving an idea what is ready today. What we've got now is versioned objects database in the Nova scheduler and Oslo libraries, so that it's easy to do rolling upgrades. Okay. So it helps with upgrade the infrastructure. For the moment, the VM evacuation is manual. So there's still some work to be done, which will come later in later versions. So we will be having automated failover for VMs later on. We will also have versioned objects for other components like cylinder, ceilometer, etc. We'll have the capability to have policy-based configuration of I/O ports. So a lot of work is in the works, well, in the pipeline, to get these capabilities by the end of the year or beginning of 2016. And this will help to industrialize deployment of OpenStack components and environments. So that's really things we are contributing to OpenStack community. Storage, challenging area, and also storage has never been sexy in the last 3 to 4 years, I think, with the growth that we've seen. So one thing that has become popular is Swift storage, with the Swift interface, object storage. What we've been working on since last year is a kind of an SDS controller, so software-defined storage controller, which allows you to do policy-based control of Swift environments, Swift instances. Okay, so it's a first step. So in all this you can find on GitHub or somewhere. Erasure coding, right? Erasure coding is much more efficient than hardware-based RAID deployments for scale-out storage, large amount of storage, like 50% more efficient. So we've got instruction libraries to accelerate storage instructions, ISA-L. And the erasure coding part is something that we open source, so just the erasure coding bit. This is open sourced, and you can make use of it. We've got other things like power and thermal aware scheduling, PTAS. Nice new acronym, if we still needed one. So this is something else that can help with making sure that you keep control of power consumption and keep it under control. Yes, so the SDS controller I was referring to, it's open source. The erasure coding bit that we have in our ISA-L library, the erasure coding bit is open source, yes. And then also VSM was getting there, is also open sourced. One example of a customer is, for example, Fujitsu, who is using it for one of their appliances for Ceph. Okay, so these are really, indeed, solutions you can find as open source contribution from Intel. Then networking. So a lot of effort has been spent in virtualizing the networking stack, but also making sure that it can be deployed on x86 servers and that you can get close to what we call wire speed. Okay, and it was actually quite challenging at first sight. But we've developed something called DPDK, Data Plane Development Kit, which is also open sourced. So there's a website, dpdk.org, where you can find information the packages, etc., etc. So, and DPDK is meant for customers who really want to optimize network appliances, network environments. And we've seen benchmarks, POCs, where we've been able to get a 10x packet performance improvement and a 4x reduction in CPU utilization, so that you keep more CPU cycles free for your applications. So it's quite, yeah, it can be quite astonishing results you can get with DPDK here. It's especially very efficient if you've got a lot of small packets, because with a lot of small packets, obviously you tend to have a higher overhead, and we can do things like CPU pinning, so that we can dedicate certain cores to just packet processing, and that way take away a lot of the overhead. SRIOV, single root I/O virtualization, it has been around for a number of years for Microsoft, for VMware environments, also for Linux. This is really how you get the highest networking performance in an Intel-based virtualized environment. Basically, what we're doing is we're bypassing the hypervisor. Okay, so Intel had to develop the drivers for example, VMware. So these have been available for a number of years, but now we have also the equivalent driver package available for OpenStack, so that you can also benefit from SRIOV in an OpenStack environment. Cryptography, compression, already mentioned quick assist technology. So for the moment, this is available as a PCI Express card and a kind of accelerator, which can give you, 50 gigabits per second compression capabilities and things like that. So you just add it as a card to your existing server. We've got Linux libraries so that you can also do your own development and integrate certain encryption algorithms into your own applications. Okay, and CPU pinning, already mentioned, NUMA awareness and things like that. So what you see here is that, for example, as a result of the DPDK, we've been able to get these performance to make an open vSwitch environment like 10x more performant and reduce CPU cycles. So result is lower latency and much higher throughput for NFV, for network function virtualization. In summary, so Intel's approach to SDI, right, it's really where we want to move to a world where the application defines the system. Okay, if you need storage efficiency, then you go to a storage server which has erasure coding or other things integrated, who has AES to do the encryption acceleration and things like that. We want to work with the broadest enabled ecosystem, be it open source or commercial. We're going to continue work to make, let's say, telemetry, to make more functions available and easily accessible, right, out of band, so that cloud service providers can take advantage of this information in real time and without, let's say, disturbing, let's say, the OS environment. So we've got the OpenStack layer, orchestration layer. The hardware attributes are available or visible to those. And then depending on if we're talking about storage, network, or compute, you've got different levels of technology or platform attributes which are relevant. I'm also going to make you aware of some of the software solutions that we have available, which are not open source, but which are commercial or closed source, if you want to say. So, for example, we have things like Intel Cache Acceleration Software, which is a caching software to make use of SSDs. You leave the hard disk-based storage capacity in place. You install this caching software, you attach it to an SSD, and then you basically get a lot of the benefits of a full SSD-based environment. So this is something that things are maybe lesser known, but that Intel also has available. Intel Lustre. So Lustre is a distributed file system, mostly used in HPC environments. So for customers who would be in that business, would be a good thing to look at this Lustre. We also have a cloud edition, by the way. Next generation NVM, so non-volatile memory technologies. We've announced it a couple of weeks. 3D crosspoint technology, okay, which is a new class of storage class memory devices, which will be launched early next year. So obviously we will be working on the OpenStack side to make those technologies available and exploitable as well. So, but this will quite dramatically change, I think, the way we look at storage or what we can do with storage, because now we have technology which is almost as fast as DRAM, but it's non-volatile, and it has much higher density and will be lower cost than DRAM. So exciting technologies to look forward to beginning of 2016. Already mentioned our storage acceleration library, which is not open source, but we open source the erasure coding bit. DPDK, and next year we'll be launching Intel Silicon Photonics to change, let's say, the way computers connect to each other and can use optical connections rather than the current traditional copper or fiber connections. In the compute side, we've got integrated graphics on the Xeon E3, okay, which can do very efficiently transcoding TXT for trusted compute at platform level. AVX and AES-NI are the other instruction sets which can help accelerate security and encryption. So, as a result, what we see is that there's a lot of momentum behind OpenStack. Intel's contributing, I think, quite significantly to it. And what we see is that it has matured quite a lot over the last, let's say, 3 years. We see more and more enterprises deploying it. We see cloud service providers developing, I don't know, really large scale-out storage environments, for example, on top of OpenStack. So I've got here a couple of quotes. I like this, the one in the middle, saying that we truly believe that OpenStack is becoming the Linux of cloud computing. So it's really getting enterprise ready. So we really have to, I think the technology components are there also from Intel to make it more secure, more deployable, more highly available. So the key takeaways, actions is, well, deploy OpenStack on Intel architecture-based platforms. You've seen we do a lot of optimization to make it highly performing, reliable, scalable. And since it's based on x86 architecture, we see a lot of, let's say, adoption also with network, also for network appliances. So you would have the same architecture and resource pool across network, storage, and compute. So it's easily interchangeable. Get educated today, right? I hope you've learned a couple of new things that you may not have known about Intel, about our contribution or what you could use to develop your own OpenStack with Intel contributions. One very useful website is 01.org. Okay, that's where we try to combine or centralize all our open source developments from Intel. Okay, and if you do /OpenStack, then you will see all the content and contributions relative to OpenStack. And then also, start with deployments and start talking to your service providers or solution providers to get POCs ready. And if you need help, we're there to help as well with your solution providers. Thank you. And any questions about? No? Okay, so the question is, there's no GPU acceleration. No, obviously we're not in the graphics cards business, but we do have graphics engines in the Xeon E3, as I mentioned. Okay, and these are our way of accelerating the graphics capability. So we are focusing on transcoding because we've seen a huge need for transcoding because a lot of the content in the cloud is video, right? And it takes up huge chunks of bandwidth. But I think we're improving also on the graphics capability. So I think today our latest generation V4, Xeon E3 V4, has capabilities you can compare with any entry-level discrete graphics card from NVIDIA or another vendor. So it is there, but you need to know which CPUs to look for because it's just specific CPUs in the E3, Xeon E3, like we recently launched the Broadwell generation, the V4, and it's only 3 CPUs, okay? But we have what we call embedded DRAM in those CPUs, which gives very high bandwidth memory to the, well, actually not just the GPU engines, but even the CPU. And you find the same technology in the Core i7, for example. So we call it Iris Pro. Iris Pro first appeared on the mobile, on the desktop, which was launched, I think, first of all by Apple, okay? Now this capability is, since a couple of months, available as a Xeon E3 processor, the V4 generation. So if you want to have the highest end Intel-based offering, that's where you should look. And then next year we'll have Skylake with even much better improved performances. But yeah, you just need to look for Iris or Iris Pro. That's the easiest way, I think, to identify our high-end graphics capabilities. And by the way, people are starting also to do programming in OpenCL on the GPU engines as well. Okay, if that's what you want to do, then there is a way of doing it in OpenCL. Yeah. More questions? Thank you. Thank you for your attention.